start recording. See, I'm rusty. And now we have the domain being limited to x greater than 0. What's the range for this parabola, given where the vertex is? Okay, because the bottom of the vertex is at -7, the range is y is greater than or equal to -7. That's the bottom of the range. All right, so that's the function. We now want to find its inverse. To find its inverse, you're going to switch the x and y variables, and you're going to switch the domain and the range. And so the inverse, instead of being y equals 3x squared minus 7, becomes x equals 3y squared minus 7, so you've just switched. And the domain is now x greater than or equal to -7, and the range is y greater than or equal to 0. So you've switched the domain and the range, the values, and you've switched the variables. Your last part would then be to get that in the switched equation to get y by itself. And so you're going to do some quick math to both sides. Okay, probably add 7, so x plus 7 equals 3y squared. Divide by 3, x plus 7 divided by 3 equals y squared. And then you'll apply the square root. And the square root would be the plus or minus, because there's always 2 when you take the square root of something, x plus 7 over 3, with the new domain and the range that you've already had. So now that I have my inverse with my restricted domain and my restricted range. So that would be a sample. Okay. Another example of getting an inverse might be y equals e to the x squared. And this is an exponential graph. Just like I expect you to be able to picture a parabola, not to graph it perfectly, just to have a picture. A parabola shaped like a U opens up. Okay, an exponential. Okay, an exponential function, you should at least have an idea or a working knowledge that all exponentials start out flat and then eventually shoot up towards infinity. Just an idea. Exponentials have that excited shape where they're like tooling along pretty level, and then zoop, they hit that one. We're going to learn what the name of that point is, okay, where it takes its heads up to infinity at that rapid rate. But that is what an exponential looks like. All right, the domain of an exponential is all real numbers. I write all real numbers as a scripted R. I don't mind if you write the words all real numbers. I don't mind if you write -infinity to +infinity. It doesn't matter to me how you communicate all real numbers. I hopefully will understand what you mean. But I usually just write a scripted R to be all real numbers. The range of this function, because it's starting off relatively flat with a horizontal asymptote and then shoots up, the range is y is greater than but not equal to 0. It never touches 0. So to find, because this passes both the HLT and the VLT, I can find the inverse. So I'm going to switch the values of my variables. So switch the y and the x around. And so I'm going to have now x equals e to the y squared. And now I want to get y by itself. All right, you tell me, what do I do to both sides of this equation to get y by itself? Apply the natural log. All right, very good. The natural log will be applied to the side of x, and the natural log will be applied to the e to the y squared side. What that does is the property of the natural log of e to the y squared, all powers can get pulled to the front. That's one of those properties of logarithms from Ham that allows you to pull it to the front. So we now have the natural log of x, and then we've got y squared in front of the natural log of e, and I think Ms. Price called that linear with you. Okay, that linear is always equal to what value? 1. And so the natural log of e is 1, so we now have just y squared by itself equals the natural log of x, and then we can use the plus or minus square root one more time. So we have the plus or minus square root of the natural log of x equals y. And we switch our domain and our range. And so the domain of this would be what the range used to be. So x greater than 0. And the range would be what the domain used to be, which would be all real numbers. Any questions about inverses? Do you remember the notation for when the books, when they want you to find an inverse, how they would write that? Instead of f of x, what do they put? Like if this question had been, so if they'd used f of x notation, instead of y, if they had f of x here, and then you solved, and then instead of y, do you remember what that would be? With a little -1, right? So they would have f with a little teeny negative, see if I can get a -1 there. That's the notation also for inverse. So that would be inverse as well, if you see that. All right, last thing. This is usually his favorite, is just solving. All right, this is like there's an answer and you can solve it and you can do cool math to both sides and you need to figure out what x is. So people usually enjoy doing these kind of questions. So solving, getting x alone. The last part of your homework is going to be this type of thing. I have 2 examples to show you. Some of these will be easy for you and some of them are going to stretch you a little bit and be more challenging. So here's one that should be relatively easy. All right, 2.018 to the t minus 1 equals 3. I guess I shouldn't say getting x alone. It should be getting the variable alone. In this case, the variable is t for time. And so we want to work on getting the variable by itself. The variable is in the power. We call this an exponential. And the only way to undo an exponential is to use a logarithm. I know that there are options for logarithms. Your calculator has a couple. It has common log, which is log base 10, and it has natural log, which is log base e. I'm going to tell you from here on out, please don't use common log. It doesn't exist in calculus. In the subject level of calculus, there is no common log of 10. There's only the natural log. And so I'm just going to say don't get into the habit starting day 1 not to use common logs anymore. So we're just going to use the natural log again, just like we did. So I'm going to use the natural log in front of 2.018 to the t minus 1. And then I'll use the natural log in front of 3. And when I use a natural log, it allows me to pull the power of t minus 1 to the front. And so I will have t minus 1 as a power in front of the natural log of 2018, 2.1018, and then the natural log of 3. Then I can do a quick division of natural logs. So I'll divide both sides by the natural log, which will give me t minus 1 by itself, and I'll have the natural log of 3 over the natural log of 2.018. I would prefer that you did not evaluate that with your calculator. I don't really care what the decimal is. The AP people aren't going to really care what the decimal is. They want to know what the exact value is in its fraction form. So just leave it like that. Because every time you use a calculator, you round and you lose accuracy. This is more accurate than any calculator, to leave it in this form. And then just add 1 to both sides. So the right form of the answer would be the natural log of 3 over the natural log of 2.018 plus 1. And that's how you'd want to leave it. If you want to get a decimal approximation for that so that you feel better about checking your answer or something, that's, I guess, okay, but it's really preferable to leave it like that. Okay, and I only just have one more example. So that one should have been like, okay, I've gotten the cobwebs out. I feel that looks pretty familiar to me. I think I could probably do that. This next one is going to be brand new. I don't think you've ever seen this kind of question before. So this is our final example, and we're going to solve 5 to the x plus 5 to the negative x equals 3. Okay. Now, if it was just this, if it was just 5 to the x equals 3, what would you do to both sides? Natural log, okay? The problem is this extra thing here, this plus 5 to the negative x. You cannot take the natural log of 2 pieces, so it would be illegal to do a natural log on both of those. That would be incorrect. It would also be incorrect to try and do a natural log to like all of it at the same time. You can't take the natural log of the sum either. All right, so that's why I'm just going to show you how to do this. What do negative powers mean? What do negative powers mean? 1 over. Okay, so let's take care of that first. So this is 5 to the x plus 1 over 5 to the x equals 3. So now I've gotten rid of the negative, but I've created a fraction. And I don't really care for fractions all too terribly much. Okay, fractions are, if we have the chance to get rid of a fraction, we can. So how do we usually get rid of fractions in problems? Multiply through by everything. So we're going to multiply this problem by what number or by what expression? 5 to the x. We're going to multiply everything by 5 to the x. So I'm going to put a bracket around the whole thing. I'm going to multiply by 5 to the x. I'm going to distribute that 5 to x inside to this whole problem. So I've got 5 to the x times 5 to the x. What do you call it when something is multiplied by itself? A square. All right, so when something is multiplied by itself, we now have 5 to the x squared. Plus, now we have 5 to the x times 1 over 5 to the x. What does that give me? 1. And then at the opposite side, we have 3 times 5 to the x, which is not 15. Okay, 3 times 5 to the x is not 15 to the x. It's 3 times 5 to the x. That's what it is. Okay, what do you do with any problem that has a square in it? Not square root. Okay, what do you do with a problem that has, we call it a polynomial when it has a square in it. So what do we do with any problem that has a square in it? Okay, first you need to set it equal to, okay, how do we set this equal to 0? Okay, subtract. So 5 to the x squared, I'm going to put the minus 3, I'm going to put this 5 to the x in parentheses, okay? Plus 1 equals 0. So this is a polynomial. Something squared minus something plus something else equals 0. This is a polynomial. It has a square and it's equal to 0. How do you solve every square that's equal to 0? Not every square. Some squares factor when they're set equal to 0. How can you solve every square that's set equal to 0? It's over there. Right? Yellow poster, red sign, emergency use only. What does it say? The quadratic formula. All right, so the quadratic formula is what we're going to have here. All right? So we're going to have, we're almost done. How does the quadratic formula go? X equals negative b. What's negative b right now? Negative 3. So that's 3. Plus or minus the square root of b squared, which is 9. Okay, minus 4a, what's a? It's 1. Okay, and c is 1 all over 2a equal to, now it's not equal to x, what's being squared? Not just x, what's being squared right now? It's equal to 5 to the x. So this becomes 5 to the x equals 3 plus or minus, what's 9 minus 4? 5 over 2. We're almost done. So it's a quadratic, only it's equal to 5 to the x instead of x. Now how do we get rid of the 5? Remember at the beginning I said if it was just 5 to the x, wouldn't it have been easier? Now we just have 5 to the x. So what do? We do a natural log. And so now we can do the natural log. So we're going to have x natural log 5 equals the natural log of all of that, 3 plus or minus rad 5 over 2, and then we get x by itself by dividing by the last natural log. So the answer looks ugly, but there's beauty in it too. And that is x by itself. All right, I told you that one was going to kick your butt.